This video is about how to real-life applications of exponentials and logarithms, okay? I think you'll never use this, but it does have application in real life. So really, we just got a couple examples to look at. All right, first of all, financial. Let's say you deposit $500 into an account that pays 6.75% interest, compounding continuously. That's a good deal. How long will it take you to double your money? All right, so if you recall, there's a good old equation we talked about. If it compounds continuously, we use this one. The A is the balance of the account equals the principal, what you put in initially, times E raised to the rate multiplied by the time. All right, so when you, first thing you're going to have to do is identify what the different values are going to be. All right, so A, what is the amount of money I want it to be? Well, I'm looking for how long it's going to take to double my money. So how long is my T? That's the unknown here, okay? The amount I'm looking for is double whatever 500 is, which we know is 1,000. The rate is 6.75%, but I have to convert that to a decimal, so 0.0675. And then the principal. How much did I initially put in? $500. All right, so these are my values. I need to just write them into my equation, and then we're going to solve it. So 1,000 equals 500 times E raised to the 0.0675 times T. All right, so now we have a good old exponential equation we need to solve. And just like before, we need to isolate that exponent. So I need to get rid of the 500. So I'm going to divide by 500, and I'm going to get a 2 equals E raised to the 0.0675 T. Now, if you recall, what did we do to get the T out of the exponent? If you remember, we had to take the natural log of both sides of the equation. So we did the natural log of 2 equals the natural log of E raised to the 0.0675 T. So natural log of 2 stays put. I'm just going to scooch it over here. So I have the natural log of 2 equals, natural log of E is just 1, so the power drops down. And I can solve this now for T. So I simply need to divide by 0.0675. And that'll tell me what T is. Okay? Now, once I put that in my calculator, the natural log of 2 divided by this decimal, I get this number, 10.269, blah, 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 blah. All right? But the question is, how long is it going to take? So this is, T is in years, my number of years. So when we're doing application problems, you want to answer in a complete sentence. So what I would say is, it will take approximately 10 years to double the money, or double the investment, however you want to say it. But yes, you need to write it in a complete sentence. Okay? It will take approximately 10 years to double the investment. You will see this more and more. So hopefully that makes sense. Make sure you have, if you have questions, ask them. Okay? Next example. All right, the number of endangered species in the U.S. from 1990 to 2002 is modeled by this equation. This is a good example of how research projects use logarithms and exponents. All right, so this example, this equation shows how to figure out how many endangered species there were between 1990 and 2002. So they want you to look at this. If T is 10, that's reflecting 1990. If T turns out to be 22, that's referring to 2002. So if you need to write it out, do that. So 1990 is 10, 91 means 11, 92 is 12, on and on and on. This will come back at the end of the problem, so we'll try to figure out exactly what year we're looking for. So the question is, during what year was the number of species 357? That's what y equals, is the number of species. All right? So what I need to do is set up my equation. So 357 equals negative 119 plus 164 natural logs of T, solving for T. I need to isolate that T, so first thing I'm going to do is add 119 to both sides. When I do, I get 476 equals 164 times the natural log of T. I need to get that isolated, so I'm going to divide by 164. That's gone. 475, some decimal. But now I have to get natural logs of t. Now, to get rid of the natural log, if you recall, what we need to do is make e the base, so that will cancel out. So e is my base. I'm going to raise this to the exponent, and all of this is now an exponent to e. All right? When that happens, this part will cancel. So I need to figure out e to the 475ths, 164ths. Equal. That's what e is, or t, my time, is going to equal. So you'll type this in your calculator, being very careful with the fraction. When you do that, you get t equals 18.219. All right, so you cannot leave your answer like this because this is meaningless. What does 18.219 mean? You need to go back to what they were saying about the years. If 10 is 1990, what is 18? Well, 18 is 1998. All right, so the question is approximately what year was the population 357? It was 1998. So again, application problem, I want to write in a complete thought. So I would say during 1998, the number of species was 357. Do you have to write in a complete thought? Yes, unless you want points deducted, you have to write in a complete thought. I'm not asking for a paragraph or a paper, just a sentence that makes sense. All right? Okay, for the whisk, you try one of these endangered species problems. Okay, again, I'm asking what year was the number of species approximately 380. Okay, here's the equation. It was y equals negative 119 plus 164 natural logs of t. That was the equation, and remember, if t was 10, that was 1990. If t was 22, that was 2002. All right, so make sure your answer is as a year. That's what I'm looking for in the whisk, is what was the year. All right, good luck and see you in class.